Hello students, welcome once again Akshar IIT online classes. I am your chemistry faculty S. Mohan. Students, actually we were discussing in the chapter solutions, right? And in that solution, the last topic what we discussed is factors of solubility. Yes, so solubility means what? The amount of solute that can be dissolved in a given volume of solution is called solubility, right? So, what are the factors? This also we discussed: nature of solute, nature of solvent, temperature, and pressure. And we have discussed about these are all discussed up to Henry's law. Okay, so till here we discussed, and today we are going to discuss about the vapor pressure of a liquid. So we are going to discuss about what? Vapor pressure of a liquid, right? So students, first, what is meant by the vapor? Yes, what is meant by the vapor? Good. So when the water is boiled, the water is converted into the gaseous state. So liquid is converting into the gas, right? So water is converting into gas. That's called water vapor. Now vapor pressure. What is the vapor pressure? The pressure exerted by the vapor is called vapor pressure. So vapor pressure of a liquid. So very simple. You take one liquid, right, and you boil it. So then what happens? That converted to vapor. That vapor exerts a pressure on the remaining liquid. So that pressure, the pressure exerted by the vapor is called the vapor pressure of a liquid, right? So see here now, the pressure exerted by the vapor when in equilibrium with the liquid at a given temperature is called vapor pressure. Is this clear? So here see students, here for example I am taking, this is one beaker. What I am taking? I am taking one beaker. Now in this we take certain amount of water. For example, I am taking the water. You can take any liquid, but I am taking water. Right. Now I'll close this. Beaker with a lid, airtight lid. Right. Now, before that, what we do is, let's imagine that it is open. It's open. Okay. And now I start heating this one. Example thing that I am starting. Okay. So I am heating this one. Right. I am heating. Imagine first it's open. It's open. Right. I am heating this one. On heating, what happens? Water will be converted into vapor. When boils, the water will be converted into vapor. Right. And here it is open. So what happens that vapor? That vapor escapes. Yes, it's go away from the beaker, right? So continuously if you boil, continuously water get converted to vapor, and this vapor as it is open, it's escaping from the beaker. And after some time what happens? The total water get evaporated. Now nothing is left in the beaker. Is this clear? Yes. Now that's the first situation. Now let's go to the second situation. In the second situation what we do? We take the beaker and we take the water. Now, but this time what we do is, we close the lid tightly. We close the lid tightly. Yes. Now we start heating this one. So now what happens? The temperature rises and it starts boiling. The boiling means what? Where the liquid is converting into the gas, right? So now this water is converted into the gas, and the gas is moving, okay, from the liquid, above the liquid. But here what happened here? The lid is there, so that is closed, right? Now can this water vapor escapes outside? No, there is no chance to escape the water vapor. Yes or no? Now like this what happens? The water will be converting into vapor, and the total vapor is accumulated, okay, here. Means what? The total vapor is gathered here, right? Now still if you are heating, you think, then what happens? Now this total empty space is occupied by the vapor. The total empty space is occupied by the vapor. Then what happens? Then what happens? Here, still if you heat, some of the liquid will be converting into the gaseous state, means vapor. And as there is no place, some of the vapors again it will be converted into the liquid state. Okay. So liquid is converting into the gaseous state, and already converted gas is converting into the liquid state. So this cycle will be going on continuously taking place. Is this clear? So how much liquid is converting into the vapor? The same amount of vapor is converting into the liquid. So the process will continue inside. Clear to you? Then we can say that it is under equilibrium. Equilibrium. Did you listen the word equilibrium? Equal. Okay, equilibrium. That stage, which stage? Where the amount of water converting into vapor is equal to the amount of vapor converting into liquid is called the equilibrium. Is this clear to you? At this stage, now what happens? This vapor exerts the pressure on this liquid. So this pressure exerted by the vapor is called vapor pressure of a liquid. Clear? Very simple, no? Just we are taking some liquid in a closed lid with some gap, and we are heating. So this water is converting into the, means liquid is converting into vapor, and this vapor exerts the pressure on the surface of the liquid. This is called vapor pressure of the liquid. How simple? No? Okay, once again see the definition. The pressure exerted by the vapors when in equilibrium with the liquid at a given temperature, okay, is called the vapor pressure of liquid, and it is depends upon the nature of liquid and the temperature. Right? Chalo. Now we go to the lowering of vapor pressure. Lowering means what? Decreasing. So the vapor pressure, decreasing of vapor pressure is called lowering of vapor pressure. How it takes place? Let's see now. So see students, here I am taking, for example, water. Example I am taking pure water. This is pure water. Okay. So I am taking the pure water. So here, if we heat it, if we heat this one, then what happens? So first what happens? The water molecules which are present on the surface, okay, of the water, these water molecules get evaporated. So see here, these all water molecules are there. So these molecules are getting evaporated. Clear? Sorry. So these are getting evaporated. So now for example, imagine, just I am counting here. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, something. Okay. So some molecules are getting evaporated, and this vapor is exerting the pressure here. Okay. So let you think the pressure exerted by this pure water is P naught. What do you take? P naught. P to the power of 0. Okay. P naught. Right. Now what I am doing? I am taking the solution. Solution already we discussed, a homogeneous mixture of two or more substances. Right. So here I am taking some salt. I am taking. Okay. Which is non-volatile. Non-volatile means what? Which not quickly evaporates, means converted into the gaseous state. That's called. So here I am taking some salt. For example, you think I am taking in this water, I am taking the salt, I am stirring so that I prepared a solution. This is what salt solution. This is what salt solution. Right. Now here if I heat, then what happens? Here also the water get evaporated. Yes or no? But the amount of water vapor, when you compare the amount of water vapor, what here, okay, we get the vapor. If you compare with this one, okay, this is less than this one. Okay, the vapor pressure of this one is less than this one. Okay, now the question arises why? So now see students, here the vapor pressure of this one is more than this one. Now see, observe carefully here. Here I have taken pure water only. I have taken. What I have taken here? Pure water. Means on the surface, how many water molecules are there? For example, imagine there are 100 molecules are there. So this is a surface. On the surface, total 100 water molecules. So if I am taking the pure water, okay. So these 100 molecules are getting evaporated, right? Now this vapor molecules, 100 vapor molecules are exerting the pressure. So this is called vapor pressure of the pure liquid. Is this clear? Means solvent. Now, here in this I have added the salt. Now this is a solution. So now here on the surface, which molecules are there? Only water molecules are there? No, water is mixed with the salt. So here this surface now consists of water molecules as well as the salt molecules. Yes or no? The surface consists of what now? Water molecules and salt molecules. Clear? Okay, see once again. See, for example, we have one tub, you think, just one tub. Okay, in this you are keeping only red color balls, you think, like this. Okay, red color balls you are keeping here. Okay, these are only red color balls I am keeping here. Okay, now just see on the surface, only on the surface how many balls are there, red color balls. So let imagine that here some 100 balls are there, 100 red color balls are there, right? Now what I do, I'll take the same, okay, same tub. Now in that what I do, I'll mix some blue balls also. So now I'll mix some blue balls also. So now what happens here, some red balls will be there and the blue balls will be there. Okay, so here what happens now? Now see now. So here now two balls are there, red and blue balls. Here only if I taken the red balls, so total 100 red balls are there on the surface. Imagine that. So here I have taken the two balls. Okay. So now how many red balls are there? Whether 100 are there? No. Some of the place is occupied by the blue balls also. Yes or no? So total surface is occupying 100 balls. Okay. But here in that red balls, how many are there? Now it is reduced. Is this clear to you? The number of red balls are reduced. Here 100 because all are red balls only. But here you are mixed with the blue balls. So the number of red balls are decreased. Clear? So similarly, if I am taking only water molecules, the surface consists of only water molecules. If I am taking only water, okay, then surface consists of only water molecules. Only water molecules are getting evaporated, more water molecules are getting evaporated. So that exerts the pressure. The pressure of the pure solvent is more. Clear? But here what's happening? We are taking the solution, salt solution. So when I am taking the salt solution, only water molecules, so surface is occupied by both the molecules, water molecules mixed with the salt. So salt molecules also there. But on heating what happens? Only water molecules are getting evaporated. Yes or no? So on surface now less amount of water molecules are there. Now they exert the pressure, but the pressure is less because only less water molecules are only getting evaporated. So those molecules only exerting the pressure. So here the number of water molecules which are converted into vapor is less. Here the number of water molecules which are converted into vapor are more. So the pressure exerted by this one is greater than the pressure exerted by here. Is this clear to you? Any doubt? So here the pressure exerted by the liquid, okay, the solvent, for example, if take, so that is called partial pressure. What it is called? Partial pressure. Clear to you? So that is the difference. Now lowering of vapor pressure. See now, when a non-volatile solute is dissolved in a volatile solvent, non-volatile means what? Which cannot get evaporated easily. Volatile means what? Which can get evaporated easily. Okay. So here what I am taking, for example, I am taking water and I am taking some salt. Okay. So then what happens here? So salt may not get evaporated easily, but water get evaporated easily. Is this clear? Okay. So for example, you take water and alcohol. For example, if you take liquid and liquid, okay, alcohol and water. If you mix, both will be mixed and we get the solution. And if you heat it, then what happens? First, alcohol will get evaporated. Okay, because alcohol boiling point is less. So alcohol is more volatile than the water. Is this clear to you? Okay. Now see, a non-volatile solute is dissolved in volatile solute. Then what happens? The vapor pressure of the solution is less than the vapor pressure of the solvent. Just what you know, vapor pressure of the solution is less than vapor pressure of the solvent. Clear to you? Why? Reason here it is explained. Just now what I explained, that is the reason here. Okay. So when a non-volatile solute is added pure solvent, some of the solvent molecules on the surface are displaced by the solute molecules. So if you take These are the solvent molecules. Now, if you are adding salt, so you see some of the places are occupied by the solute molecules, right? So, due to that, what happens? Solvent molecules will be decreases. Okay. Now, when, okay, so the number of molecules of the solvent per unit area will be less compared to the pure solvent. So, here the red molecules are less compared to this one. Okay. So, hence, fraction of the surface, okay, solvent solution is blocked. So, this is called, so what happens, the vapor pressure will be decreases. Clear, no? Very easy concept, right? So, this is about the lowering of vapor pressure. So, lowering of vapor pressure, in short, it is called LVP and it is denoted by delta P. Okay, the triangle shape is, no? The triangle shape is called delta P. Clear now? Any doubt here? So, now how can you define the lowering of vapor pressure? Okay, so at pure definition now you see here, the difference between the vapor pressure of a pure solvent and the vapor pressure of the solution, then the difference is called lowering of vapor pressure. Clear to you? So, lowering of vapor pressure means what? First, the vapor pressure of a pure solvent we calculate. Then we calculate the mixture, means what? Solution now, solution. So, that is less. Now, that difference, okay, is called lowering of vapor pressure. Is this clear? So, for example, you see now here, let, I said, let the pressure, the vapor pressure exerted by the pure solvent is P naught. The vapor pressure exerted by the, okay, solution is P. Now, difference, in the mathematics, difference means what? Subtraction, right? So, in the subtraction, so now delta P is what? Lowering of vapor pressure. So, lowering of vapor pressure is equal to P naught minus P. So, P naught is what? Vapor pressure of pure solvent. P is what? Vapor pressure of solution. Vapor pressure of solution. Okay. So, if you subtract the vapor pressure of solution from the vapor pressure of pure solvent is called, we can get a lowering of vapor pressure. So, see here, if P naught is a vapor pressure of solvent, P is a vapor pressure of solution, then lowering of vapor pressure is what? Delta P is equal to P naught minus P. That's all. This is called as the lowering of vapor pressure. Clear? Any doubt? Okay. So, now at any given temperature, the vapor pressure of the solution decreases with increase in concentration of solution. The meaning is what? If you take 100 ml of water, if you take only pure water, 100 ml of water, and if you heat it, if you boil it, the pressure exerted by the pure water is more. If you add 10 grams of salt, then what happens? Little the vapor pressure will be decreases. If you add 20 grams of salt, now salt occupying more space, still the vapor pressure of liquid will be decreases. If you are increasing more, 30 grams, so again still the vapor pressure will be decreases. Means what? As the increase in the concentration of the solution, the vapor pressure will be decreases. Okay. So, lowering of vapor pressure increases with increase in concentration of solution. So, that is, student, about the lowering of vapor pressure. Clear? Any doubt? Very simple, no? The vapor pressure exerted by the pure solvent, pure liquid means one type of liquid, is always greater than the vapor pressure exerted by the solution. Now, the difference between these two gives the lowering of vapor pressure. How simple? Okay, right. Now, students, I am going to explain you the very important law that is called as the Raoult's law. What is called? Raoult's law. Okay, Raoult's law is a very important topic. So, here actually here derivations are there, but these derivations are not required for your standard. Okay, because as you are in IIT, so we need only to solve the problems. So, for that need not to learn the derivations. Clear? Derivations are not at all required, only formula. What is the formula? That formula is required. Okay, like this you can find so many derivations in the chemistry, even in the physics also I think, but that is all not required here, only the formulas you need to remember. But briefly I will explain you the derivation. These derivations you need not to practice. Okay, not required at all. Okay, only formulas to be learned. Alright. So actually Raoult's law what it states? So Raoult's law what it states is, so here you see, Raoult's law states that the relative lowering of vapor pressure of the solution containing a non-volatile solute is equal to mole fraction of a solute in the solution. Okay, did you understand? No, I think. No? No problem. I am here to explain you. So students, already we discussed about the concentration of solutions. Okay, like we discussed like concentrations of molarity, mole fraction, normality, okay, molality. This all we discussed. These all are the water. These are the ways of expressing the concentration. Okay. So here what it states is relative lowering of vapor pressure. Just now we discussed with the lowering of vapor pressure. Lowering of vapor pressure is what in the previous slide I have shown that pure vapor pressure of pure solvent is what? P naught. Right. And vapor pressure of the solution is what? P. Right. Now the lowering of vapor pressure means what? Subtract, I said. So you have to subtract. Now, but it is given relative. Relative means what? We have to compare this one with the pure vapor pressure of the pure solvent. So we are comparing, okay, with the vapor pressure of pure solvent. So this part is called relative lowering of vapor pressure. What is called? Relative lowering of vapor pressure. What is relative lowering of vapor pressure? Okay. So see here now, very simple. Lowering of vapor pressure already we discussed. Okay, just now I told you that the vapor pressure of the pure solvent is more. So let the pure vapor pressure of pure solvent is P naught. And vapor pressure of the solution is less. The vapor pressure of the solution is P. Lowering of vapor pressure means how much it is less. So what you do, just you have to subtract. But it's given that relative. Relative lowering of vapor pressure is just you have to compare with the P naught, divide with the P naught. So now this part is called the relative lowering of vapor pressure. So P naught minus Ps. Of course, here is given Ps, but okay, we can write P also, no issue. Clear? So this is about the relative lowering of vapor pressure. Now Raoult's law what it states here? Raoult's law states that relative lowering of vapor pressure of a non-volatile solute is equal to mole fraction of the solute. Mole fraction of the solute. So now let's revise now. Mole fraction already we discussed, we have done numericals also on that one. So mole fraction is what? For example, there is one solution is there. Okay, there is one solution is there. In this solution means what? A car which consists of two or more substances, right? Let's imagine that there are two substances are there. One is A and the second one is B. One is A and second one is B. Let A is a solvent, and B is a solute. B is a solute. So the number of moles of solvent is given by Na. Number of moles of solute is given by Nb. Total number of moles of solution is given by Na plus Nb. Now if I want the mole fraction of solvent if I want, then what can I do? Na by Na plus Nb. If I want mole fraction of solute I want, then what can I do? Nb by Na plus Nb. Okay. So this is a mole fraction of a solvent. This is what mole fraction of a solute. Mole fraction explained that it is denoted by chi, the symbol which is looks like a X, right? So now what is given? So mole fraction of solute, if you are taking this as a solute, is equal to Xb. Clear? But what is Xb? Xb is this one. So now write here this one. So then what happens? P naught minus P divided by P naught is equal to Xb. Xb is what? Nb by Na plus Nb. Okay. So here you see now. Okay. P naught minus Ps by P naught is equal to Nb. In the place of B, they have taken 2. In the place of A, they have taken 1. So then it becomes N2 by N1 plus N2. That's all. So this is about the relative lowering of vapor pressure, Raoult's law. Is this clear to you? So this is the today's topic. With this synopsis, this part of synopsis is done. So once again today, what I explained you briefly within 2 minutes, I'll explain you. So just listen to me now. So vapor means what? when you when you boil the liquid, that liquid is converting into the gas. That is called vapor, right? And if you heat in open vessel, then that will get escape. But if you heat in a closed vessel, then that vapor do not escape because the lid is closed. So that exerts a pressure on the liquid. So the pressure exerted by that vapor is called vapor pressure of the liquid, right? Now, for example, if we are taking only one liquid, let me imagine that we are taking a water, then the pressure exerted by only water, okay, is called the vapor pressure of the solvent, okay. So vapor pressure of the solvent. But if you take the mixture means what? If you add something in that, then here now what happens is the surface of the molecules will be occupied by the solute also, okay. And which solute we are adding? We are adding non-volatile solute, means what? Which cannot evaporate quickly, okay. So now what happens? The vaporization means the evaporation of water will be less. Like now the vapors of water will be, means the solvent will be less. This is called lowering of, that's the vapor pressure of, that's called, okay. Now the difference between these two is called lowering of vapor pressure, okay. So that is, difference means subtraction, okay. So the vapor pressure exerted by the pure solvent minus vapor pressure exerted by the vapor of the solution, okay. So that is called lowering of vapor pressure, right. Now based on that Raoult, okay, Raoult's law is there. So Raoult's law states that the relative lowering of vapor pressure is equal to the mole fraction of the solute. So now relative lowering of vapor pressure can be denoted by P naught minus P by P naught is equal to vapor pressure of the solute, that is denoted by XB. But XB is what already we learned, that mole fraction is equal to number of moles of solute by number of moles of solute plus solvent in solution. So that is NB by Na plus NB. So this is the formula, students. So with this, the synopsis 3 is completed, right. Now let's have some questions, right. So let's have some questions. If you have a material, just open the material, page number 35, page number 35. Once you open, chalo, time is less, so we solve it fast. Chalo students, so if you have material, open the material and these are the questions. So see here, among the following naphthalene is soluble in, naphthalene is soluble in, this already discussed, like what do you say, that like dissolves in like. Did you remember? I said that salt will be dissolved in water, but salt will not be dissolved in kerosene or petrol. Yes, similarly, naphthalene is dissolved, not dissolved in water, but it dissolves in benzene. Where it dissolves? Benzene. So the answer is 3. Option is what? 3. What's the copy the answer? The answer is 3. Right? Then, second question. So answer is 3. This is the right answer. Now next one, among the following substances solubility in water decreases with increase in temperature. Yes, we discussed on 3 types of, okay. The temperature also will affect, as the temperature increases for some solutions, the solubility also increases. For some solutions it remains constant, for some solutions it decreases. So example, serous sulfate, okay. So the answer is 4. Where I explained you, if you want me to show, I'll show this also. Here you can see. See here, it is decreasing, coming down. Here all are increasing. See, it's going up, it's going up, it's going up, it's going up. Okay. So which is decreasing? This is decreasing. So serous sulfate is decreasing. This is there in your material once you check. And sodium chloride remains the same. Okay. Sodium chloride remains the same. So what's the answer now? Answer is serous sulfate. Okay. Now 2.5 grams of sodium chloride is dissolved in 25 grams of water. So now what is the solubility? So what is the solubility for this one? Okay. So 25 by 2.5, 2.5 answer, 2.5 10 sir. So answer is 10. Okay. So the answer is first option. Okay. Now the next one you see fourth question. What is the fourth question? The aqueous solution of methanol. Aqueous solution of methanol in water has a vapor pressure. Okay. So this just now I told you that normally. So here methanol is belongs to the alcoholic, okay, alcoholic group. So it is more volatile. So here the answer is more than that of the water, okay. So the option is 3. Check students, fast. Now next question is what? The relative lowering of vapor pressure is equal to mole fraction of solution. Just how I told you. Relative lowering of a pressure is which law this is? Raoult's law. So the answer is what? Raoult's law is the right answer. Okay. Yes. Now next question you see now. The vapor pressure of any volatile constitute one solution at a constant temperature is equal to the vapor pressure volatile. Okay, that is mole fraction. Just now we discussed this also. Mole fraction of that component. Okay. Then come to the next 7th one you see here. Raoult's law is applicable. This directly can say that is generally dilute solutions. For which solutions? Dilute means what? In which okay, some other solutions are mixed. Next one you see the relation shape which describes the variation of vapor pressure with the temperature. This is actually not given here. So here the answer is this one. Okay. So this is not given in your textbook. This one is not discussed. This is just out of the syllabus, right? Then the vapor pressure of the liquid depends on what? The surface of the container, volume of the container, temperature. The answer is all. Answer is what? All. And 10th one you say which characterizes the weak intermolecular force of attraction of a liquid. Okay, which characterizes the weak intermolecular force of attraction. If the force of attraction is more, the boiling point is also more. If the force of attraction is less, the boiling point is also less. If the boiling point is less, then more vapor exerts. Easily the water means liquid will be converting into the gaseous state. So the answer is high vapor pressure. So answer is 2. Okay. Now the last and final one, the water will boil. The water will boil at 101.5 degrees at which of the following pressure? So 76 centimeters, 76 mm. It is wrong because 76 centimeters greater than 76 and less than 76. So water will boil. So here if that pressure is more, the boiling point will be decreases. So I think this already you have learnt in the somewhere lower classes. If you go to the higher altitudes, okay, if you go to the higher altitudes, the boiling point will be increases. Yes or no? So generally if you go to the higher altitude, if you want to cook something, okay, it's better to cook in the pressure cooker than the normal vessel. Did you come across this point anywhere in any lower classes? If you want to cook something at the higher altitude, means you are going like big tall height mountains, there if you want to cook something, then it's better to cook where in the pressure cooker than the normal vessel. Why? Because here as you go up, the pressure will be decreases. Okay. So the answer is this one. So this is the right answer. Okay, students. So with this, more are there still? No. Okay, students. So with this chapter, this synopsis 3 is done. So remaining, you have a practice sheet for you. Let's try. So try that yourself and practice. If you have any doubt, we discuss in the next class. So next class we are going to start the 4th synopsis. Acha, one important thing is that this week you'll have a continuously chemistry and maths class only. Okay. This week remaining class also. Today is Wednesday, Thursday, Friday, Saturday, and have only math and chemistry class only. Okay. Next week we'll have the physics. Right. Okay then. Bye. Take care.